Welcome to a new video. In this video we will continue to take a look at properties of logarithms. We will see two rules in this video. In number 11 we see that a to the power of logarithm x in base a is equal to x. In other words, if the base of the number and the base of the logarithm are same, then the result is equal to logarithm of the number that we are trying to take. For example, in this regard we can say that 2 to the power of logarithm 5 in base 2 is 5, or 3 to the power of logarithm 7 in base 3, which is 7. So that number, which is the base, okay, in an exponential form, and the base of the logarithm, if these are same, then the result is equal to the number that we are trying to get the logarithm. There is a rule, of course, in this example as well, which is that number, okay, a cannot be equal to 1. And by the way, all the numbers are positive real numbers. And again, here a and b, we see b in rule 12. So the base cannot be equal to 1. In all logarithms, the number that is in base cannot be equal to 1. So from this regard, in number 11 and number 12, the numbers a, b should be different from 0. Other than this, all the numbers should be a positive real number. Again, for number 11, we can write that 100 to the power of logarithm, let's say 10, and the base of the logarithm should be 100 as well. If this is the case, then the result is going to be equal to 10. All of those examples are about number 11, and now let's take a look at a case for number 12 as well. Let's say 5 to the power of logarithm in base 425 is equal to. In such expressions as well, we can just switch the base number with the number that we are trying to get to logarithm. In this case, it is 25. So we can write base as a 25 and 25 as a 5. And this is going to be equal to 25 to the power of logarithm 5 in base 4. These are equal to each other. And now let's take a look at examples related to these properties. Okay, in this question, we have two terms, 2 to the power of a logarithm plus x to the power of another logarithm, and this is equal to 16. So in this case, what is the result of x? In such questions, we see that here we have two terms. Try to make the terms same, okay? Try to get the same terms. How? In the first one, we see that the base is 2. So how can I make x 2? By using the 12th rule, I can switch those numbers. So let's do it in the next step. I'm writing the first one as it is, 2 to the power of logarithm of x in base 3 plus, now I can switch x and 2, so it's going to be 2 to the power of logarithm of x in base 3, which is equal to 16. And now, as you can see, we have two same terms, so that means we can add them up. So there is going to be 2 times 2 to the power of logarithm x in base 3, which is equal to 16. And now I can divide both sides by 2, so that 2 cancels that 16, and that 16 is going to be 8. Let me continue here. So it's going to be 2 to the power of logarithm of x in base 3. Now this is equal to 8. We all know that 8 is 2 to the power of 3. So it's going to be 2 to the power of logarithm of x in base 3 is equal to 2 to the power of 3. If you remember from the powers and exponents, if the bases are same, so the powers should be same as well. In that case, logarithm of x in base 3 has to be equal to 3 by using that rule. So logarithm of x in base 3 is 3. And then what we were doing was just send this 3 to the right. So it's going to be 3 to the power of, bring that 3 as a power. So it's going to be 3 to the power of 3. And then just send this x as it is to the down. So x is going to be 3 to the power of 3 equal to 27, guys. Therefore, x is equal to 27 in this case. Now let's continue with the next question. In this question, again, we have two terms and we are asked to find the summation of those two terms. Let me remind you something about e. E is a constant number, which is 2.7, and it goes to infinity, which is an irrational number. We also know that logarithm of x in base e is represented as natural logarithm, which is shown as ln. Actually, we will see natural logarithm in our upcoming video, but because there is a ln used here in this question, then I need to explain it a little bit. So we can say that, logarithm of 5 in base e is ln 5. So whenever we see that there has to be x here, natural logarithm, which is abbreviated as ln, then we need to understand that this is a logarithm where the base of the logarithm is e. Let's start to solve the question. In the first term, we see that 10 to the power of logarithm 3, but we cannot see any base here, okay? So if there is any base written here in any logarithm, then there has to be a base. Actually, there is a base which is equal to 10. So in the next step, I can write that the first term, which is this term, is equal to 10 to the power of logarithm 3 in base 10. This is called the common logarithm. Okay, let me just write it here. Logarithm of 5, for example. This is actually logarithm of 5 in base 10. So if there is any base written in any logarithm, then that means actually there is a base, and that base is equal to 10. Plus, now I'm going to write the second term, e to the power of ln 2. Instead of ln 2, I'm going to write logarithm of 2 in base e. For the first term, we have 3. Why? Because the base of the number and the base of the logarithm, they are same. So the result is going to be equal to the number that we are trying to get the logarithm, which is 3. Plus, here in the second term, we have the same thing. This is equal to 2. And if you add them up, you get 5 as the result of the question. Just let me tell you a couple of things about ln as well. So as a result, guys, to make it shorter, we can say that e to the power of ln x is equal to x all the time. Why? Because ln is the logarithm that where the logarithm has a base e. So from this point of view, we can say that e to the power of ln, let's say 100, is equal to 100 as well. Now let's continue with the next question. In this question, again, we are asked to find the value of this. So in the first term, we see that the base of the number and the base of the logarithm are same. So from this term, we already have 1 divided by 3 by using the 11th property. Plus, for the second term, we can write the second term as 3 to the power of 1 times 3 to the power of logarithm of 2 in base 3. And this is equal to, because if you remember the powers and exponents, if the bases are same, then we were adding the powers up. This is going to be equal to 1 divided by 3 plus, from here we already have 3 times, from this part, okay, we already have 2. So we have summation and multiplication. According to the order of operations, multiplication comes first, and that means 1 divided by 3 plus 6, which is equal to, just multiply 6 by 3, 18, so it's going to be 1 plus 18 divided by 3, which is 19 divided by 3, and that is the final answer. And now let's take a look at the next question. 2 to the power of 3 times 2 to the power of logarithm of 5 in base 2 plus 3 to the power of logarithm of 2. I'm going to write square root of 3 as a power, okay, so it's going to be 3 to the power of 1 divided by 2. Plus, actually, this one was in our previous example. We can easily write that e to the power of ln 6 is 6, guys. From the first term, 2 to the power of 3 is 2 times 2 times 2, which is 8. 8 times, and here, this term, okay, in this term, the bases are same. The base of the number and the base of the logarithm, they are same, so this is going to be equal to 5. Plus, in the next term, we have 3 here, and then if we can have 3 in the base of the logarithm, then we can easily solve the rest of the question. Okay, so I need to get rid of that 1 divided by 2 as a power in the base. So if you remember, we were writing it as 3 to the power of 1 divided by 1 divided by 2, guys, times logarithm of 2 in base 3 plus 6. So this is going to be 40, guys. This is going to be 6. So if you add them up, then we're going to have 46, of course, 46 plus. Now I'm writing the leftover as 3 to the power of, here if you divide 1 by 1 divided by 2, just let me write it here, 1 divided by 1 divided by 2 is 1 times 2 divided by 1, which is 2. So here I need to write 2 times logarithm of 2 in base 3. And now again I need to get rid of that 2. How? Just send it as a power to number 2. So this is going to be equal to, guys, 46 plus 3 to the power of logarithm of 3. Now 2 to the power of 2, which is 4, guys. I need to write here 4. And now this is going to be equal to 46 plus, and now the bases are same, okay, the base of the question and the base of the logarithm, which are same, and then that means we can write the result as 4, which is the number of the logarithm that we are trying to get. So the result is going to be equal to 46 plus 4, which is 50, guys. And now that's the last question in this topic. We will continue to the subtopics in the logarithms as well. There are a couple topics that we need to cover to finish the whole properties about logarithms. Thank you for watching, and hopefully see you in the upcoming videos.